Gy's sampling theory is a theory about the sampling of materials, developed by Pierre Gy from the 1950 seconds to beginning 2000 seconds in articles and books including 1960, Sampling Nomogram, 1979, Sampling of Particulate Materials, Theory and Practice, 1982, Sampling of Particulate Materials, Theory and Practice, Second edition, 1992, Sampling of Heterogeneous and Dynamic Material Systems, Theories of Heterogeneity, Sampling and Homogenizing, 1998, Sampling for Analytical Purposes. The abbreviation, TOS, is also used to denote Gy's sampling theory. Gy's sampling theory uses a model in which the sample taking is represented by independent Bernoulli trials for every particle in the parent population, from which the sample is drawn. The two possible outcomes of each Bernoulli trial are 1. The particle is selected, and 2. The particle is not selected. The probability of selecting a particle may be different during each Bernoulli trial. The model used by Gy is mathematically equivalent to Poisson sampling. Using this model, the following equation for the variance of the sampling error in the mass concentration in a sample was derived by Gy. $V equals frac 1. Sum I equals 1, NQI Mi2, sum I equals 1, NQI1 QI Mi2 left AI frac, sum J equals 1, NQJ a JMJ, sum J equals 1, NQJ MJ right 2. In which V is the variance of the sampling error, north is the number of particles in the population before the sample was taken. QI is the probability of including the ith particle of the population in the sample, i.e. the first-order inclusion probability of the ith particle. Mi is the mass of the ith particle of the population, and I is the mass concentration of the property of interest in the ith particle of the population. It is noted that the above equation for the variance of the sampling error is an approximation based on a linearization of the mass concentration in a sample. In the theory of Gy, correct sampling is defined as a sampling scenario in which all particles have the same probability of being included in the sample. This implies that Q, I, no longer depends on I, and can therefore be replaced by the symbol Q. Gy's equation for the variance of the sampling error becomes $V equals frac 1 QQ M text batch, 2, sum I equals 1 NMI, 2 left, AI a text batch, right 2, where a batch is the concentration of the property of interest in the population from which the sample is to be drawn, and M, batch, is the mass of the population from which the sample is to be drawn. It has been noted that a similar equation had already been derived in 1935 by Castle and Guy. Two books covering the theory and practice of sampling are available. One is the third edition of a high-level monograph, and the other an introductory text. Hello, I'm Hart, and I'm here to guide you through the secret formula for perfect samples.